we're going to assign something called formal charge to every atom in the structure. So how do we know which one is dominant? We're going to calculate formal charge. So when you have the ability to draw more than one Lewis structure for a compound, how do you know which one is valid? Well, resonance structures are Lewis structures that only vary by where the electrons are. So what we're going to do is to determine which one is valid or dominant, we're going to assign something called formal charge to every atom in the structure. So let me give you the formula for formal charge. We're going to take valence electrons, which we get off the periodic table, subtract non-bonding electrons, and then subtract the number of covalent bonds. So this formula, write this down. We're going to do this in a real live example, and I think that you will understand. So let me go ahead and give you an example. NCO is a polyatomic ion with a -1 charge. And if I were to sit down and draw Lewis structures, I could draw 3 Lewis structures. And there they are. So how do we know which one is dominant? We're going to calculate formal. Show you how to do that for the nitrogen for each atom in each structure. So let's go to the first one on the left, and we'll call this guy A, and we'll call this guy B, and we'll call this guy C. So here we go. So formal charge, we're going to use our formula here. The number of valence electrons that nitrogen has is 5, right? We get that off the periodic table. And then we're going to subtract what? Non-bonding electrons and covalent bonds. Non-bonding electrons, we have 2, 4, 6, and then we have 1 covalent bond, and so that would be 7, and that would give us a -2 formal charge. This is what I'm calling formal charge. And you're like, wait a minute, aren't these covalently bonded? There's no ions here. I know. It's kind of like if it were an ion, what would its charge be? Just hang with me. All right, the next one, I'm going to show you a little simpler way of doing it. For carbon, the valence electrons is 4. And then let's see, we have no non-bonding electrons. We just have 1, 2, 3, 4 covalent bond. So his formal charge is 0. For oxygen, valence electrons, periodic table says 6. We're going to subtract those 2 non-bonding electrons and then 3 covalent bonds. So that would be 5. And that is a +1. So these are the formal charges of these atoms. Now, if you add them all up, -2, 0, and +1, you get -1, which is the overall charge for that polyatomic ion. Now, we've got to do this for all of them. So here we go. I'm just going to do the 5 valence minus, let's see, we've got -4, 5, 6. So that is -1. 4 minus 4 is 0. 6 minus 6 is 0. Okay. 5 minus, well, I've got 2 non-bondings and 3 covalents. 0. 4 valence and 4 covalent bonds. 0. 6 minus 7 is -1. Okay, so I've done formal charges for all the atoms in all the possible Lewis structures. Now, what do we do with this? If the one that is the most dominant is the one that has the formal charge closest to 0. Okay, so look at these. Can we eliminate? Well, the first one has a -2 and a +1. The other two have a -1 and some zeros. So I think we can eliminate A because that one is not closest to 0. But then I think we're down to a tie between B and C because they both have zeros and then 1 -1. So what can we do here? The one with, if it's a tie, this is my second rule here, the one with the negative charge on the more electronegative element. Now, nitrogen and oxygen are side by side on the periodic table, but oxygen is to the right, which is more electronegative. So the one that has the oxygen on it is the winner. And so this one, the oxygen has the negative charge, and so it is more electronegative. And so this one would be the dominant. This would be my winner. So this is how we use formal charge to determine which resonance structure is dominant.